Hi, once again, welcome to the Varania's Potan Educational Academy. This is Guntuka Srinivas. Let me introduce myself in this session. I did my BTech from JNTU, Hyderabad campus, Jawaharlal Nehru Technological University, Hyderabad campus in civil engineering. And I did my postgraduate program, MTech, from NIT Warangal, popularly known as National Institute of Technology. And I myself having more than 20 years of teaching experience in teaching various engineering subjects in the prestigious engineering colleges. I worked as associate professor, and I myself trained many students across the country for the GATE, Graduate Aptitude Test in engineering, an entrance examination for admission to the MTech programs. And also I trained for IES, Indian Engineering Service Examination. I myself popularly known as Guntukasa throughout the country. And here it is my simple effort to give my best of knowledge to the students. This is a free educational channel encouraging the students from the 8th, 9th, 10th, 11th, and 12th standards to improve their subject knowledge, the physics, chemistry, and mathematics. The students who cannot afford the high coaching fees and those who want to enter into the prestigious IITs and NITs in the country, who want to study themselves in these institutes, whose target is IIT and NEET examinations. For them, this channel is very helpful. And here I request you people, please encourage the channel, like it, share it, subscribe the channel, share it with your friends. This is my a very simple attempt to start coaching for the IIT and NEET examinations. Let us come to the subject. In this session, let us deal some concepts related to the kinematics. Let me take up the kinematics. What is kinematics? Kinematics is simply defined as motion. It is simply defined as study of motion of objects without considering considering the cause of motion, without considering the cause of motion. Observe carefully the definition. It is study of the motion of the objects without consideration of cause. That means whatever the forces that are responsible to have the motion, those will not be taken into consideration. Simply, we are analyzing only the motion without its cause. This study itself is known as the kinematics. Clear? Observe that before going into the details of the kinematics, let me define two terms. One is rest and the other is motion. One is rest, the other is motion. What is meant by rest? Rest. When do you call an object is at rest? If an object does not change its position as the time passes, then it is said to be at rest. So clearly, if the object does not change its position as the time passes, then it is known as at rest. Example, observe here. Example, suppose a car is present here. Suppose a car is present here. This is ground. Car is present here. Now, at the present time, at T1 time, that is at this present moment, car is here. Even after 1 hour after T2 time, also the car is here. Even after 10 hours, T3 time, the car is here on. That means the object is not changing its position as the time is passing. This is known as the object is said to be at rest. This is the meaning of rest. Yeah. Anything. Suppose you have placed a book. Here I show you. Let us say there is a table. This is a table. This is a table. You have placed a book on the table. This is a book. This is a book. This is table. You have placed a book on the table in your room. Let us say this is your room. This is your room. The book is not moving as the time is passing. The book is not moving. Then the book is said to be at rest with respect to the room. The book present on the table is said to be at rest with respect to the room. That is the meaning of the rest. Here I define in a simple words. When object does not change its position, as time passes, Be careful. Very, very important. This is object is not changing its position as the time passes. This is nothing but rest, meaning of the rest. Clear? Let me take up another concept, motion. Motion. What is the meaning of the motion? Same example I would like to take that. Let us say this is a car. Let us say this is a car present on the ground. Okay. Now, this is the position of the car. Now, at t1 time, the car is present here. As the time is passing, the car is moving to other place. The car is moving to the other place. The time is t. As the time again passes, the car again moves to the other position at the time t3 will be the time. That means as the time is passing, t1 to t2, t2 to 3, as the time is passing, the position of the object is changed. Then such object is said to be in motion. Here I clearly write, here I clearly define that as or if object changes its position as time changes. If the object changes its position as the time changes, then it is said to be in motion. That is the simple difference of rest and the motion. Now, you may get a doubt. All the objects are perfectly in the rest, in the absolute rest, or all the objects are in the perfectly in the motion. That we cannot say. Why? Because here I quote one simple example. Here I quote with simple example. Observe that let us say this is one room. This is one room. And there is a chair. There is a chair. And you are present in this. You are sitting yourself there. And this is a chair. There is a room. And the chair is present in the room. And you are sitting on the chair. With respect to the room, if you think you are sitting in the chair, you are at rest. Is it clear? With respect to the room, when you are sitting in a chair, you are at rest because your position is not changed. But if you think that earth is rotating, if you observe yourself that something is there on the moon, if you observe from the moon, then you are said to be in the motion. That means earth is rotating. If you observe from the moon, objects are rotating in the room. That means the example tells that there is no absolute rest, there is no absolute motion. Here I give a statement that there is no absolute rest time and absolute no absolute motion. No absolute motion. Here I quote another example also, a simple example. Let us say that you are present in the car. You are sitting in the car. With respect to the car, you are at rest. But the car is moving with respect to the ground. With respect to the ground, you are in the motion. That means everything is with reference. Everything with respect to the observer you are doing. Clear? I think you have understood the terms rest and motion carefully. Okay. No, in a simple life, observe, in our daily life, you come across there are several examples of motion. Examples of motion. Number of examples you can quote in the motion. For example, observe your body. For example, observe your body. First thing here I quote, your body. Air is flowing inside your body. Air is flowing inside the lungs, flowing, coming out, going, coming out. All this is the air. Air is flowing. Blood is flowing through the veins and the arteries. Clear? Everything is in motion. And observe surroundings also. If you observe surroundings, surrounding air is flowing in the motion. Water is flowing in the rivers. When you observe a tree, leaves are falling from the tree. And if you think bikes are moving in the roads, cars are moving, automobiles, flights are in the motion, what not? Most of the cases in our day-to-day life, you can see most of the cases in our day-to-day life, cars, bikes, flights, they are in the motion, right? Surroundings, water flows, okay? Air flows. Here, in the body, your body, air flows, blood flows, All these are the examples of the motion. Here, but remember always, when you think of rest and the motion, in the present session, we are interested only in the motion. We are interested in the motion. Here, our present interest is only the motion. And in this motion, we study different parameters. Here I quote parameters. To be studied. Parameters to be studied. Here I quote one by one. First one is position. Second is the distance. Third is displacement. displacement. Fourth is speed. Speed. Fifth is velocity. Velocity. Sixth, acceleration. Acceleration. Seventh, relative velocity. Relative velocity. All these are the parameters that are to be studied in the analysis of motion. Have the clarity and observe carefully that here motion motion can be defined or analyzed in three ways. One-dimensional motion. One-dimensional motion. 1D in 1D plane. One-dimensional motion. This is a straight line motion. We call it as a straight line motion. Straight line or linear, or simply we call technically rectilinear motion. Rectilinear motion. It only analyzes the motion of the objects in the 1D plane. Clear? The second we come across is the 2D, two-dimensional motion. Two-dimensional motion. In this case, we analyze, example, a circular motion of a body in the circle. It is going in the x direction, it is going in the y direction. Two-dimensional motion. Suppose you are going for a projectile. A projectile, this is a projectile. This is circular motion. Circular. So projectile motion and circular motion both are example for the two-dimensional motion. That means you can have the motion in the x direction as well as in the y direction. X as well as in the y direction. This is the two-dimensional. We are also going to study the two-dimensional motion in the next coming sessions. Thirdly, we observe three-dimensional motion, three-dimensional motion. Three-dimensional motion, x, y, z axis. Is the motion in the x-axis, y-axis, as well as z-axis. These are x-axis, y-axis, and z-axis also. Yeah. So 1D, rectilinear motion, two-dimensional motion, as well as three-dimensional motion. We are going to observe. Is it clear? Okay. Now, let me take a simple parameter in this session. Let me introduce a simple parameter because we have several parameters. Let me introduce a simple parameter in this session. The first parameter here I would like to introduce is position. Position. What is meant by position? To locate any object, to locate the address of any object, we need its position. Example, I want to locate your address. How can I locate? Suppose if I say some X is present, where is present? Because X is present, I must say with the reference line. Let us say X is present. Where is present? He is present in Hyderabad. In Hyderabad, where he is present? In the Abyss. He is present in the Abyss. In the Abyss, where is present? In his home. In home, where is present? In his room. Which room? Corner. That means if I want to specify the address of an object, then that itself is known as position. And remember, the position is always expressed. Position is always expressed with respect to with respect to a reference plane. A reference frame. Very important. With respect to a reference frame. Without reference frame, you cannot mention the position of an object. Yeah. Observe. Here I take up a simple example. Let us say that this is x-axis, this is y-axis, here this is z-axis, this is RS. Generally, we take up x, y, z, three-dimensional coordinate system as a reference plane. Observe. Let us say an object is present here, whose coordinates are x, comma, y, comma, z. Let us say I'm giving some name A. At A, the object is present whose coordinates are x, comma, y, and z. Okay. This is origin 0, 0, 0. If I join this origin to the A, this is known as position of the object with respect to the coordinate system. X, Y, Z coordinate, three-dimensional coordinate system. And observe, as long as the coordinates of the object does not change with respect to the frame, the dimensional frame, then it is said to be at rest. That means the x coordinate, the y coordinate, the z coordinate are present. We are locating for an object. If those are not changing with respect to time, at t time you have x, y, z same coordinates. Even after 1 hour also same coordinates. Even after 10 hours also same coordinates. If the coordinates are not changing, then the body is said to be at rest. Yeah. Similarly, suppose any one of the coordinates, either x, y, or z, or all of the coordinates, if they are changing with respect to time, that means from one position to other position object is changing, then that is known as the body in the motion. The body is in the motion. Clear? Now observe. Here I write if the coordinates of object does not change with respect to time, then it is known as the body is at rest. It is at rest. Clear? If one or more than one coordinates are changing with respect to time, then the body is said to be in what? In the motion. Because object is changing. X coordinate or Y coordinate or Z coordinate or all the coordinates are shifting from one position to the other position. That means object has come into the motion with respect. Even after the time passes, coordinates are not changing means the object itself is at rest. No change at all. This is the difference between the rest and the motion. Rest and motion. It means with respect to a three-dimensional coordination system, XYZ system, you can locate the position of object. That is known as the reference system. Clear? Always that is known as a reference system. Okay. Now observe. Observe. Here we are talking about the position. We are talking about the position. Here we are talking about the position. Suppose if you think of one dimensional, if you think of only one dimensional, that is, we come across only x-axis. Example, x-axis. Observe. Suppose this is x-axis. This is x direction. Here I am taking origin. This is origin. This is positive side of the x-axis. This is negative side of the x-axis. X bar I am indicating. That means, suppose an object is present from origin towards positive x-axis at this point. Let us say object position is at A. Object is present at A towards positive x-axis. What is the reference point, reference frame which you are choosing? O is origin is reference. That means from the origin towards positive x-axis, we are locating the A. We are locating the position of this A is taken with respect to position of this A is taken with respect. Similarly, suppose if an object is present, let us say, if the object is present, let us say, at this point, B, towards negative x-axis, this will be the position of the B measured from origin. That means O is a point with respect to O, either the position of A or the position of B can be expressed. O is the reference frame, and the position is with respect to the reference frame, either towards positive x-axis or towards negative x-axis. We, depending upon the situation. Is it clear? Right? Simply for the one dimension. Example. Observe. Let us say here in two-dimensional. In two-dimensional. The reference frame is two-dimensional frame. Two-dimensional frame. Observe. This is x-axis. This is y-axis. Let us say a point A is given, whose coordinates are, let us say, x comma y, x comma. Observe, parallel to the x-axis, this is x. Parallel to the x-axis, this is the x coordinate. Parallel to y-axis, y coordinate. Position of A is x coordinate comma y coordinate defined, and that is indicated in the xy plane, two-dimensional xy plane. Now, I want to locate the position of this A. I want to locate the position of this A. How can I locate? I would need a reference point. Your reference point is origin. Your reference point is origin. Origin is reference point whose coordinates are 0, 0. Clear? I know I locate this A's position with respect to origin. From origin up to the A vector. This is known as position vector. Tail is from O origin to the up to the point A, the head up to the A, tail to head a vector. And let us say this is R1 bar. R1 bar is known as position vector. Here I clearly write R1 bar is known as position vector. Position vector with respect to 2D reference frame. That is nothing but OA bar. OA. O to A. Tail to head. OA. Here, OA bar. Observe carefully. I have located a point A whose coordinates are x comma. What is x? Measured parallel to the x-axis, x coordinate. What is y? Measured parallel to the y-axis, y coordinate. X comma y are coordinates of the point. Is A. No, I want to locate this point. That point can be located with respect to origin. O, 0, 0, those coordinates. By drawing a simple vector, tail from the origin up to the head to the A, indicating it as R1 bar, position vector, OA bar. Direction is from O to A. Clear? OA bar is a position vector. Now, if A is set to be at rest, then the coordinates x, y should not change. The coordinates x comma y should not. That is the meaning of the rest. The first case we have seen rest. Suppose if A is in motion, means the A is shifting from A to the other position. The A is shifting from A to the other position. Here I am showing. That is, this is x-axis, this is y-axis, R is 0, 0. Let us say point is A, whose coordinates are x comma y. Let us say this is the position vector OA R1 bar. Let us say the time At A, let us say T1 is the time. At this time, position of A is here. Clear? Now let us say that A is changing its position. Let us say it is moving to B. It is moving to B position. The coordinates, let us say, they are changing. The coordinates are also changing. Let us say x1, x bar, comma, y bar are the coordinates. And as the coordinates are changing, time is also changing. At t1 time, the coordinates are x comma y, position is at A, object's position is at A. As the time is passing, t1 to t2, as the time is passing from t1 to t2, position of the object is changing, A to B, coordinates are x bar comma y bar. Clear? Now, if I draw a vector starting from origin to up to the B, tail is from the origin up to the B, and this is known as position vector R2 bar. R2 bar is a position vector, OB bar. Direction is from O to B. Clear? R1 bar. Earlier we have seen OA bar, position vector. R2 bar, OB bar, position vector. As object is changing, its position from A to B. When object is changing the position from A to B, that is said to be in the motion. This is motion. If the object was only at the A, there is no change in the time, as if the time also changing, there is no change in the position of the object, it is at rest. But as the object is changing from A to B, it is changing from T1 to T2. Then the coordinates are also changing. Then it is in the motion. Clear? Then it is in the motion. And remember, when object is changing from A to B, if I connect this, with this from A to B with a vector, A to B is a vector. This is known as displacement vector, delta R bar. Displacement vector, delta. Why? Because object is from A to B, it is changing. So here I write delta R bar is known as displacement vector. That is A, B bar. Direction is from A to B. Object is changing position from A to B. Delta. Delta stands for chain. Delta stands for the chain from A to B, initial point to the final point. Here I clearly write. A is initial point. B is final point. Object is changing from A to B. Position changes from A to B. Position is changing from the A to B. A is initial point, B is final point. Clear? And that change is indicated as delta. change is delta. Okay, change is just this is a notation, simple notation, delta is the change. Clear? That is known as displacement vector. AB bar. AB bar. Clear? AB bar vector. Okay. Now observe. This is x-axis. This is y-axis. Horizon. This is A point. R1 bar is a vector. This is the B point. R2 bar is a vector. R2 bar is a vector. Let us say this is A to B. Delta R bar is A to B displacement vector. This is origin. 0, 0 are coordinates. Clear? Now, observe. This is the first vector, R1 bar. This is the second vector, R2 bar. This is the third vector. Change. Reaction. Clear? Now here I clearly write. OA bar, R1 bar. OB bar, R2 bar. AB bar, initial to final point. There is a change in position that is known as displacement. Change stands for delta R bar. So position vector, this is displacement vector. Already we have seen. Observe simple concept of here, simple concept from the triangle of addition. A bar plus B bar, tail to head is equal to A bar plus B bar, A bar plus from the triangle itself. Clear? That means I can easily say that R1 bar plus delta R bar, A bar plus B bar, tail to head is equal to R2 bar. That means delta R bar is R2 bar minus R1 bar. Okay, delta R bar is equal to R2. This is from triangle law, simple triangle law, from triangle law, from triangle. Now, observe. If I say delta R bar is R2 bar minus R1 bar. What is delta R? AB bar. What is this? OB bar. What is this? OA bar. Very basic rule. What is this? Displacement vector. Displacement vector. What is this? Position vector. Position vector showing the position of B. Position B. And what is this? This is also position vector. Position vector showing the position of position A. Position A. Okay? That means displacement vector is simply written as AB bar. Once again, I am putting simply written as difference between the final position vector and the initial position vector. Final position vector and initial position vector. Is it clear? No. A good example here I quote. Observe, suppose Mn bar is present. How can you write in the vector analysis? Mn bar is, M is initial point, N is final point. Then On bar, final position vector minus OM bar, initial position vector. Let us say another example, PQ bar. PQ bar is a vector. P is the initial point, Q is the final point. How can we write? OQ bar, final position vector, minus initial position vector. This is the simple concept in the vectors. Clear? That means in this session, we have seen position vectors to locate the position, as well as we have also seen the rest and the motion difference. We have also seen the examples for the rest and motion. Similarly, we have seen if there is a motion, there is a displacement. There is a displacement, that is position of the object is changing. Position of the object is changing from one level to the other level. The displacement vector also I have shown. Position, not only position vectors, displacement vector also we have seen. Clear? Right? So I stop this session. Hope you have understood. Observe carefully. This is theory. So fundamentally, we should be very strong before attempting the questions. Concept should be very clear. Then only you can attempt the questions very easily. And always remember, please like the channel, share it with your friends. This is a free educational channel, because in this pandemic situation, you can learn at home only. And remember, if anybody is interested to target IIT and NEET, from the basic levels, you can learn the concepts. However, whatever may be this your standard, 8th or 9th, if you are slowly introduced to these concepts, you can easily learn. So hence, I request you to subscribe the channel. Daily, you will get the videos, and encourage it, share it with your friends, like it. Thank you very much.